Let us do the seventh problem of this exercise. Show that y equal to log of 1 plus x minus 2x by 2 plus x, where x is greater than minus 1, is an increasing function of x throughout its domain. It is a question. Here, first of all, given function is y is equal to log of 1 plus x minus 2x by 2 plus x. Differentiating on both sides with respect to x, we have d by dx of y is equal to log of 1 plus x, derivative is 1 by 1 plus x, minus u by v form denominator into numerator derivative minus numerator into denominator derivative by this 2 plus x whole square, denominator square, v into u dash minus u into v dash by v square. So this is equal to LCM here 1 plus x into 2 plus x whole square, here 2 plus x whole square minus 4 plus 2x minus 2x. So this is equal to 4 plus x square plus 4x minus 4 divided by this. On simplifying, we get like this, x square by 2 plus x whole square into 1 plus x. We got x square is positive and this 2 plus x whole square is positive, and the function is an increasing function only when this is greater than or equal to 0. So 1 plus x is greater than 0. This function will be greater than 0 when 1 plus x is greater than 0. So dy by dx is greater than 0 only when 1 plus x is greater than 0, which implies x is greater than minus 1. Therefore, the function is an increasing function throughout its domain. Therefore, y is an increasing function throughout its domain. Let us see one more problem here. Find the values of x for which the function is an increasing function. Function will become an increasing function when it is continuous on or, already it is continuous on or and differentiable on or. Yes, and one more condition is the first derivative should be greater than or equal to 0. We have to find out the values of x for which it is an increasing function. That means what? Dy by dx is greater than or equal to 0. First of all, we shall write that one. dy by dx is equal to 2 into x minus 2 into d by dx of x into x minus 2. d by dx of x into x minus 2. So this is equal to 2x square minus 4x into this d by dx of x into x minus 2 is x square minus 2x becomes 2x minus 2. So here dy by for the function to become an increasing function, dy by dx greater than or equal to 0. For dy by dx greater than or equal to 0, 2x square minus 4x into this 2x minus 2 is greater than or equal to 0. So here 2x common, x minus 2 into 2 common, x minus 1 greater than or equal to 0. 4x into x minus 1 into x minus 2 greater than or equal to 0. This means what? 4 into x minus 0, x minus 1, x minus 2 greater than or equal to 0. See here a number line. Locate these points. First of all, 0, 1, 2. This is plus infinity and minus infinity. Whenever the values of x is less than 0 degrees, means negative, f dash x dy by dx, here it is 4 into x minus 1 into x minus 2. X is negative, then these two are negative, negative into negative, positive into negative is negative. For x belongs to minus infinity to 0, 0, dy by dx is less than 0, negative. For x belongs to 0 to 1, for x belongs to 0 to 1, dy by dx greater than 0 and less than 1. 0.1 something, if we take positive, negative, negative, negative into negative, positive, so it will be greater than 0. Similarly, for x belongs to 1 to 2, dy by dx greater than 1 and less than 2, positive, negative, positive and negative, less than 0. For x belongs to 2 to infinity, dy by dx greater than 2, x is greater than 0. dy by dx equal to 0 implies x is equal to 0, 1, 2, and these points are located on number line. On observing that for this interval, first derivative is less than 0. For under this interval, first derivative is greater than 0. Under this, first derivative is less than 0 and it is greater than 0. Therefore, dy by dx is greater than 0, greater than or equal to 0 for x belongs to this 0 to 1 union 0 to 1 union 2 to infinity. Next one, children, question number 8 we have done, and question number 9, it is easier level problem. Children, please try this problem. Question number 10. Prove that the logarithmic function is strictly increasing on 0 to infinity. First of all, the derivative of logarithmic function is, logarithmic function means we can take it as log x, and derivative of log x is 1 by x, and 1 by x is greater than 0 for x belongs to 0 to infinity. Clearly, only when x is positive, 1 by x is a positive number. So in that sense, logarithmic function is strictly increasing on 0 to infinity. You can write the notes for this. Question number 11. Prove that the function f given by f of x is equal to x square minus x plus 1 is neither increasing nor decreasing strictly on 0 minus 1 to 1 open interval. Please try this problem, children. Easier level problem. Which of the following functions are strictly decreasing on 0 to 90? First of all, we shall do this problem. Children, try this problem. It is an easier level problem. In the first quadrant, which of the following functions are strictly decreasing? The derivative of this cos x is minus sin x. Minus sin x. Sin x is positive in first quadrant. Minus sin x becomes negative. It is strictly decreasing. So the function cos x will be strictly decreasing within this interval, and cos 2x. Similarly, for cos 2x, cos 3x and tan x, you have to try this. Tan x is positive in the first quadrant, but derivative of tan x is secant square x. Secant square x is positive everywhere, so it is strictly increasing function in the first quadrant. And for cos 2x and cos 3x, children, please try this one. You can do this easier level question. Let us try some other problems of this exercise. Do the 13th question on your own, which is an easier level. 14th one, let us see. Find the least value of a such that the function f given by f of x equal to x square plus ax plus 1 is strictly increasing on open interval 1 to 2. First of all, given function is f of x is equal to x square plus ax plus 1, and f dash x is equal to 2x plus a. Since 1 less than x less than 2, two less than 2x less than 2 to the 4, a plus 2 less than 2x plus a less than a plus 4, we can write a plus 2 less than f dash x is less than a plus 4. For f to be strictly increasing, f to be strictly increasing, f dash x should be greater than 0. So a plus 2 should be greater than or equal to 0, we can take from this inequality. From this inequality, we can take a plus 2 greater than or equal to 0. For f to be strictly increasing function, f dash x should be greater than 0. So a plus 2 will be greater than or equal to 0. Try to understand this one. A is greater than or equal to minus 2. Least value of a. Therefore, least value of a is equal to minus 2. Let I be any interval disjoint from open interval minus 1 to 1. Prove that the function f given by f of x equal to x plus 1 by x is strictly increasing on I. first of all have to show that the function is strictly increasing on I, where I is any interval disjoint from -1 to 1, open interval here. So given function is, first of all, given function we can take it as, given function is f of x is equal to x plus 1 by x, f dash x is equal to 1 minus 1 by x square, which is equal to x square minus 1 by x square. For f to be strictly increasing, f dash x should be greater than 0. For f to be strictly increasing, greater than 0, f dash x greater than 0, for f dash x to be greater than 0, this numerator should be greater than 0, as x square is already positive, so x square minus 1 is positive, then only we can say that f dash x is greater than 0. This is possible, this is possible when x square minus 1 is greater than 0. X square minus 1 means x square minus 1 square, x plus 1 into x minus 1 greater than 0. Then x belongs to, this implies x belongs to minus infinity to minus 1, union one to infinity. Therefore f is strictly increasing on r minus of minus 1 to 1. That is, f is strictly increasing on I. This exercise 16, 17 and 18 and 19, all these are easier level questions, so students, please try these questions from the exercise and do it as homework. Write the notes for all these questions. All these questions, these models have been discussed earlier. Keep on practice. All the best.